Good everyone, and welcome to another video of Mr. Fankel's solution. As you can see, I'm having my calculator here and I'm having a phone here where I'm going to be taking out some questions, because like I said, today's class is going to be a calculation class. We're going to actually apply those formulas we have been learning. But before we actually go to our calculation class, there's a little bit of the eyes in the constants, elastic constants we're learning that we haven't actually quite touched, and when I touch them, they will go straight to calculations. Okay, so one of them is what we call the bulk modulus. I calculated the formula here. The bulk modulus is basically the stress over the volumetric strain. The ratio between the stress and the volumetric strain is given by a constant called K. Called the bulk modulus. And then there's also another constant, although it's not written here, called the modulus of elasticity, modulus of rigidity. We have met what we call the modulus of elasticity, and it is known as the tensile stress over tensile strain, stress over strain. But the modulus of rigidity is known as, the formula for the modulus of rigidity is shear stress over shear strain. That is the modulus of rigidity. Okay, so that modulus of rigidity is represented by a constant C. So there's a relationship between E and C, and relationship between E and K, also with the Poisson ratio. Okay, so this relationship can be represented by E for the bulk modulus. E is equals to 3K into 1 minus 2U, and for the modulus of rigidity, E is equals to 2C into 1 plus U, mu, and this mu, as we all remember, is the Poisson ratio. So we're going to be applying some of these formulas, and formulas we have learned in previous classes into this question. So I'm going to actually pick a question here at random. Okay, let's see which we pick. Okay, so I'll calculate the change length. Let me pick one that's going to be all encompassing. So I'll calculate. Yes, I think I found one. Okay, now I'm going to read the question, then you can take note of the question, but I'm going to write down the parameters as I'm listing it. A bar 30 millimeter in diameter. Okay, so let me read the board. The bar, question 1, a bar diameter G equals 30 millimeter. Okay, was subjected to a tensile load of 54 kilonewton. You say P tensile load 54 kilonewton. Okay, and what is stated here? The measured extension on the 300 millimeter gauge length, the length, which is what we can call it gauge length, 300 millimeter, and they say the extension measured is 0.112 E, which is the extension 0.112. I've actually done this question before, so and then the change in diameter is 0 points, then diameter, change in diameter. Okay. Yes, I'll be using, okay, we're not using the extension as E. So we use the extension as change in length, yeah. And then change in G, change in diameter is 0.00366 millimeter. The change in length is also in millimeter. Okay, so we are asked to what I was calculate. We are asked to calculate 3 things. Okay, the first one is Poisson ratio mu, bulk, and the 3 modulus, which is elastic modulus, bulk modulus, and modulus of rigidity. So this is actually going to be quite simple. Okay, there's no much stress. So the solution is as follows. Now, the first question, the first thing is to calculate the Poisson ratio. Now, to calculate the Poisson ratio is actually one of the easiest things we can actually do. Okay, because now remember what I said. Imagine I'm going to draw so that we understand some concepts. If you draw, let's draw a cylinder. Let me draw this the bar. Bar is in cylindrical form. Assuming that the bar is in cylindrical form. First, you have the diameter, you have the and gauge length. This is gauge length, this is diameter. Okay, so this is the gauge length, this is diameter. Okay. So if you apply the force 54 kilonewton here, you apply that force P, 54 kilonewton. What is going to happen is that this force is going to lead to a direct extension here, which is what we call the longitudinal strain, and lead to a strain here, which is what we call the lateral strain. And remember that the formula we give for Poisson ratio mu is longitudinal lateral strain, over longitudinal strain. Now, how do we get the lateral strain and longitudinal strain? Very simple. We have the change in length. We have the change in diameter. So we know the change here and the change here. What we have to do is to remember that strain for longitudinal strain, let's say long, which is L, which is going to be change in L over L. Just basically change in length with reference to the length. So what's the length, change in length there, as we have in question, 0.112 over 300. And if you do the math, okay, 100 millimeter. This is the millimeter. So if you do the maths, I have a calculator here, so 0.112 divided by 300. We're going to have 3.73 times 10. 3.73 times 3.733 times 10 to the power minus 4. So that's the longitudinal strain. Let's get the lateral strain. Okay, which is the strain that happens in diameter. It will give us change in V over T, 0.00366 over 30. So doing that, 0.00366 divided by 30 gives us 1.22 times 10 to the power minus 4. That is the lateral strain. So now we can get our Poisson ratio. I think mu equals lateral strain 1.22 times 10 to the power minus 4 over longitudinal strain 3.733 times 10 to the power minus 4. And when we do the math, 1.23. With the mass, we have mu equals 0. Sorry, okay, 0.327 is what I have here. Okay, so 0.327 is what we have. Okay, now we have the mu. That is the Poisson ratio, which is this. So I'm able to calculate Poisson ratio. And let's calculate the three moduli. Now let's start from E, modulus of elasticity. Modulus of elasticity is, what's the formula? The formula is simply modulus of elasticity is tensile stress over tensile strain. That's the formula. And for all those that remember, we derive it as E because P L over A the L, which we eventually changed to where we got the L as PL over AE, if you can remember in the first class. So from here we can calculate, we have P, we have L, we have A. Okay, we don't have A, we can calculate A, and then we have the L. Now let's calculate A first before we can go. Now A, since this is the cross section, so the cross section, the area of cross section is basically a circle, you have a circle. So A, I'll calculate right by D squared over 4 or pi R squared. Irrespective, if you want to divide to get the radius first, fine. If you want to go straight, fine. So I'm going to have A equal 22 over 7 times 30 squared over 4. So A will be giving me 900 divided by 4. It will give me 706.95. Okay, that's in millimeter square. So I have my area, so I can calculate my E now. Since that E equals 54 times L is 300 over A is 706.95 times changing L is 0.112. Having all this, I'll press on my calculator. 54 times 300 divided by 706.95 divided by 0.112. So I'm having my E equals 204.6. Okay, that is the unit is kilonewton, because the first unit was in kilonewton. Kilonewton per millimeter square. Okay, now we have calculated the first one, E, and of course this word will not be enough, so I need to clean. So let's clean wipe here. I really hope you understand this part, because we're wiping it off now. Now that takes us to the new formulas I introduced today, which is E equals 3K 1 minus 2 mu. Okay, and remember that we got mu as 0.327 when I position. Okay, so now we can solve for K and we can also solve for C. Let's start with K, meaning that K will become K is written as E over 3 into 1 minus 2 mu. Okay, so K is 204.6 over 3 into 1 minus 2 open bracket 0.327. So if you have that, let's press it in the calculator. Okay. 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 You have 1, 2 times 0.327 times that times 3. Okay. Sorry. times 3. It gives us this, and then we have our E 204.6 divided by my answer. She give me my K as 197.11. Okay, 197.11. I think the unit to kill is kilonewton per millimeter square. Something didn't change. And then for this, for C, you can say E equals 2C 1 plus mu, meaning that C equals E over 2 1 plus mu. So you'll be having 204.6 over 2 into 1 plus 0.327. So I'll do the math now. See the answer. 2. They are seen as 77.091. I think it's still also the Newton per millimeter square. So I've been able to solve virtually almost everything. We had to get E, we had to get Poisson ratio, we had to get modulus of elasticity, modulus of rigidity, the bulk modulus, and we got each and every one of them. And I'd like to compare what we have here to the answers they have in theirs. Okay. They're having 204.6 for E, yes, which we have. They have 77.2, we have 77.1. Okay. They have 196, we have 197.11, and I think where the issue came from is because we have 0.327 here, they have 0.326. So you can see quite close answers. Okay. So we have been able to actually apply all of them and solve all of them correctly. And if we apply these formulas this way, then surely you'll be able to solve any question regarding any of these topics. So thank you for watching today's class. I hope you really learned a lot how to apply these formulas. And see you in the next video. Remember to like, share, subscribe, and comment. Okay? Thank you so much, and watch us for other videos.